Hello and welcome to this session. In this session, we will discuss about addressing modes of 8086 microprocessor. After completion of this session, you will be able to explain the operation of each data addressing modes, how to use the data addressing modes to form assembly language statements, how to select the appropriate addressing mode to accomplish a given task. Now, there are three basic types of addressing modes: data addressing modes, program memory addressing modes, stack memory addressing modes. In this session, we will discuss only data addressing modes. Before this, we will discuss what is opcode and operand in 8086. An opcode is a operation code. It is a single instruction which can be executed by the CPU. In a machine language, it is a binary or hexadecimal value. For example, move AX, 1000H. In this example, move is a opcode which has a standard hexadecimal value called as a mnemonics, which is executed by CPU. And AX and 1000H is an operand. Why actually we go for the addressing modes? The processor will get the data of the user from different sources. Now, it can get the data from registers, it can get the data through an instruction or by an instruction, it can also get the data from input-output ports or from memory location. So, the way of accessing those operands is nothing but addressing modes. Let us start data addressing modes in 8086. There are total 7 data addressing modes. The first one is register addressing mode, then immediate addressing modes, direct addressing mode, register indirect addressing mode, base plus index addressing mode, register relative addressing mode, and base relative plus index addressing mode. First of all, we will discuss register addressing modes. When the name of the register is directly given with the instruction, such type of instruction called as a register addressing mode of instruction. For example, move BX, DX, that means it copies the data of register BX into the register BX. One more example, that is move ES, AX, that means that it copies the data of register AX into the register ES. The next example is add AL, BH, that is it add the content of register BH with the content of register AL, and it stores the data or result, into the register AL. So, in this all example, the name of the register is directly given with the instruction. So, that's why this type of instruction is called as register addressing mode type of instruction. And the most important point is the source and destination register must have the same size. These are the examples of register addressing modes. The next addressing mode is immediate addressing mode. In this type of instructions, the directly 8 or 16-bit data is given with the instruction. In this type of instruction, the source operand is a constant and the operand comes immediately after the opcode. The immediate addressing mode can be used to load information into any of the registers except the segment register and flag register. So the first example is move AX, 2550H. That is, it moves the direct data, 16-bit data, 2550 is H into the register AX. The next example is move CX, 625. It loads the decimal value 625 into register CX. The next addressing mode is direct addressing mode. In direct addressing mode, it moves a byte or word between the memory location and register. In short, the direct memory location address or offset is given with the instruction. This address is offset address. For example, move AX, 2400, that means it moves the content of DS:2400H into the register AX. In this example, the physical address is calculated by combining the contents of register DS and it shifted towards left side by 4 bits and is added with 2400H. Let us see one example to find the physical address of memory location and its content after the execution of the column, assuming that the DS is equal to 1512H. So, examples are move AL, 3BH, move 351 in bracket 3518, AL. So first it copies 3BH into the register AL. Then the content of this register AL is copied into the memory location. To find the total physical address, it adds the content of DS with 3518 to find out the total physical address, and the total is 18638H. So whatever the content of AL is copied into the memory location 18638H. The next is register indirect addressing modes. In register indirect addressing mode type of instruction, it transfers a byte or word between the register and the memory location addressed by an index or base register. For example, move AX, in bracket BX. In this, the total physical address is calculated by combining the content of segment register DS. For example, DS contains 1000H and BX contains 1234H. So the content of DX is shifted towards left by 4 bits and added with the content of register BX to find the total physical address. So the total physical address in this example is 11234H. So whatever the content of this memory location is copied into the register AX. In the next example is move CL, in bracket SI. In this example, it moves the content of DS:SI into the register CL. The next addressing mode is base plus index addressing mode. In this type of instruction, it transfers a byte or word between the register and the memory location addressed by a base register, that is BX or BP, plus an index register SI or DI. Combining base and index addressing modes, one base register and one index registers are used. For example, move BX plus BI, CL. It moves the content of register CL into DS:BX plus DI. So the physical address is calculated by combining the content of DS, it shifted towards left side by 4 bits and added with the content of BX plus with the content of register DI. So whatever the content of register CL is copied or is transferred into this memory location. These are the examples of base plus index addressing mode. Move CH, in bracket BX plus SI. move AH comma in bracket BP plus DI, move BP plus SI comma AL. These are the examples. In the last example, it moves the content of register AL into SS colon BP plus SI memory location. The next addressing mode is register relative addressing mode. In this addressing mode type of instruction, it moves a byte or word between the register and the memory location addressed by an indexed or base register plus a displacement or relative. The data in the segment of memory are addressed by adding the displacement to the contents of base or an index register, that is BP, BX, SI or DI. For example, move AX comma in bracket BX plus 4. So, it moves the contents of BS colon BX plus 4 into the register AX. So, the physical address is, it finds the physical address by combining the content of segment register and shifted towards left by 4 bits added with the content of register BX or plus 4. 4 is nothing but the displacement. So whatever the content is present on this memory location is copied into the register AX. The next example is move CH comma in bracket SI plus 5. And the one more example, move AH comma DI plus 1. It moves the content of DS colon DI plus 1 into the register AH. The next addressing mode is base relative plus index addressing mode. The base relative plus index addressing mode is similar to the base plus index addressing mode but adds a displacement besides using a base register and the index register to form the memory address. For example, move in bracket BX plus DI plus 1 comma AX. So, it moves the content of register AX into the memory location DS colon PX plus DI plus 1. So the physical address is calculated by adding the content of DS, shifted towards left by 4 bits, and then add with the contents of base register BX, and with the contents of index register DI plus the displacement, that is 1 each. So whatever the content of register AX is copied into this memory location. The next example is, similar example is, move AX comma in bracket BX plus SI plus 10. So it moves the contents of DS colon BX plus SI plus 10 into the register AX. In the last slide, we will discuss which offset register is used with the segment register. The offset register instruction pointer IP is used with the code segment register CS. The offset register SIDIBX is used with the data segment register DS as well as the extra segment register ES. The offset register SP and BP is used with